In this lecture, we will learn how to design the steel structure. So we switch off the labels and we switch off the releases to make the structure simplified. Control Shift A on a keyboard to display the shell, and after that we check the steel frame design options. This is an ordinary moment resisting frame, and the seismic zone is zone 4. Consider P delta done as yes, and left click on OK. Go to design steel frame design and start design check. So now we can see that some of the members are failing in the design and some of the members are showing very high utilization ratio like this. It is showing 0.924, and most of the members are in blue range, that is in the range of 0 to 0.5. Like here we can see that ISA 150-15010 is showing the ratio of 0.527, that is it is showing 52% utilization. And after that here you can see that it is showing approximately 1.589, which is the member is failed. And if we want to check without unlocking the model and deleting the result, what we can do here is that we can left click on overrides and design section as ISA 150-15010. So it is showing that the member is now passed, that is 0.694. So what we can do here, similarly we can check for this member also, that is ISA 75-75-6 is here. So what we can do here is that we can change these members also. Left click on overrides, current design section is ISA 100-110, and then we will see that the ratio is still very high, that is approximately 4. So again change the section here, 150-15010, the ratio is again very high, that is the member is again failed. So what we can do here is that we can assign double angle bracing here, and that we can do by unlocking the model and defining a double angle in the define section property sections. So these vertical members need to be changed as ISA 150-15010, these 4 members, and the exterior members are also getting failed here, that is 1.95. So what we can do here is that we should do the optimization process again and again. So we go to section properties and frame sections, left click on import new property, steel. Here material is Fe250 and section as steel double angle. Family should be Indian, and double angle ready-made sections are not available. So what we can do here is that we can left click on add new property. Here we can select steel double angle and then left click on OK, and here we can enter double angle of 100 and back to back distance, that is this distance. We can select the material as Fe250 and the name as 2 ISA 100, 100 and 10. Left click on OK, and then again left click on OK, and then define these sections as 2 ISA 100, 100 and 10. Go to assign frame as section property. This is already selected, and then left click on apply. And after that these sections were also failing. And these sections were also failing. So we enter double angle of 100, 110, and these vertical members are also failing. As we have assigned releases to the horizontal members, So all the forces are being transferred through the vertical members. Left click on OK and then close, and then again analyze and design the structure. So we keep on doing this cycle unless we are sure that the structure is economical and the structure is safe as per the design standards. After that we go to steel frame design and start design check. So here again some of the members are failing. Almost all the horizontal members are also failing under the condition that the section is class 4. So what we can do here is that we can check that the 110 is getting passed or not. So 110 is safe. And this section, that is 150 is passing by a very marginal ratio. So what we can do here is that we can assign double angle to these columns, and in the meantime it is also getting failed. So let us optimize these horizontal members first and these vertical members. So we assign these vertical members as double angles, assign frame and section properties to ISA 100-110, and we assign these members as hundred and 10. See, steel structures are not that easy to design. It involves lots and lots of iterations, lots and lots of repetition, and lots of revisions also by the client or as well as by the architects, that they want it like this or they want it like that. So it involves lots and lots of repetitions. You should not go for the utilization ratio more than 95%. So again we analyze the structure, and again we need to design and check how many members are still failing. Go to design, steel frame design, and start design check. So right now, as far as I can see, only two members are getting failed here. One is this member and another is this member. The ratio is 1.391. The ratio is 1.278. So there is one more thing that we can do here as a form of structural stability. We can draw plan bracings also. So take the angle of ISA 100-110 and then make the bracing like this. Similarly, we can draw the plan bracing on the opposite side also. So we can assign releases to these new bracings. Go to assign frame and releases partial facility. Left click on apply and OK. And then we go to analyze and analysis. Go to design, steel frame design, and start design check. So with this we can see that the members which were failing initially in design are now passed. So you can understand how much structural arrangement in a steel structure is important. Like we changed the structural arrangement and then all the members are now passed. So it all depends upon your engineering judgment and your engineering experiences with the steel structures, that how you can manage to get them passed as per the design standards. And I must say here that the utilization ratio of all the members is very low, and that is approximately in the range of, like here it is 0.071, here it is only 0.105. so we can reduce the sizes also of these members, and here it is only 0.105, it is only 0.06.